that example we just covered, we'll just say warm up. I just wanted to just illustrate the techniques we'll be using. Now I'm going to take it slowly and I'm just going to be more procedural. So you have this equation. You have this plot of a quadratic equation. You know it's a quadratic equation because we have a parabolic shape. We can see that the roots of this equation, the x coordinates of its intersection with the x-axis, are 3 and 7. So we know this. The equation we're looking for, so this graph has an equation. We don't know what that equation is, but we know that the roots of that equation are x1 equals 3 and x2 equals 7. Basically, the roots are 3 and 7. We know that. We also know that the point with the coordinates 2, minus 5, so 2 comma minus 5, so x coordinates of 2 and y coordinates of minus 5 also lies on the line. So the coordinates of this point, which lies on the line, must satisfy that equation as well. The first thing to do is to construct an equation which has these roots. And remember, constructing an equation from roots just simply involves doing the following. In our case, x1 is 3 and x2 is 7. This gives x squared. So if you expand it, the 2 is expanded. That's kind of a way of revision. So x times x minus 7 minus 3 x minus 7 gives x squared minus 7x minus 3x plus 3 times 7 is 21 equals 0. Simplifying this gives x squared minus 10x plus 21 equals 0. So an equation which has the roots x1 is 3 and x2 is 7 is the equation y equals x squared minus 10x plus 21. Now in the previous video, I didn't want to explain why I just replaced the 0 with the y, because I didn't want to, you didn't necessarily have to know why, but it's also good to know, so I'm going to tell you actually. Now imagine you're given this equation and I asked you to determine its roots. You would do what? You would replace y with 0 and then solve the equation you obtained. Now if you replace y with 0 in this equation, you get this equation. Therefore, the roots of this equation are the values you get by solving this equation. And we know that when you solve this equation, the x values you get are this, because we worked backwards basically. We started with the roots and got an equation. We know that if you solve this equation, you get the roots of this equation. So you don't necessarily have to know. You can just say, okay, I'm going to replace this 0 with a y. And I get an equation whose roots are 3 and 7. Let's think about it again. You have this equation, you replace y with 0, you get this. If you solve this equation using quadratic formula or any other technique, you get these values as the roots. It may take a while, but let's move on. So we have this equation. We know that an equation of this form has the same roots as this equation. So we're just going to work with this form. Now, n is not equal to 0. Just note that. But moving on, we know that this equation has the roots 3 and 7. And this equation also is such that this point lies on it. So we're going to do two things. Firstly, we're going to find n. Now, n must be such that the coordinates of this point satisfy the equation. The coordinates of this point, the x coordinate is 2 and the y coordinate is minus 5. Since this point lies on the curve, its coordinates must satisfy the equation of the curve. So to determine n, replace y with minus 5. We're looking for n, so n is an unknown, and replace x with 2. And that gives 10 times 2, so I'm just going to write 20 plus 21. And this gives minus 5 equals n into 4 minus 20 plus 21, which is minus 5 is equal to n into 5. So we have minus 5 is equal to 5n, which is the same thing as 5n is equal to minus 5, which is the same thing as n is equal to minus 5 over 5, which is minus 1. So we've determined that n is minus 1. So we've determined that the equation we're looking for is actually y equals minus 1 times x squared minus 10x plus 21. So let's just review what we've done so far. We're given the graph of an equation and we don't know what the equation is. We're trying to find out what the equation is. We know it's a quadratic equation because of the parabolic shape, but we don't know what the equation is. But we're given its roots and we're given a point on that curve. Starting with the roots, you construct an equation. The equation you construct is such that when you replace the 0 with the y, you have this equation, and this equation is such that its roots are this. Why? Because if you're given this equation, in order to determine the roots, you replace y with 0, and you get this. When you solve this equation, you get these values. So we know that this equation has these roots. But as also mentioned earlier, that for an equation of this form, of the form y equals ax squared plus bx plus c, an equation of the form y equals n times the whole bracketed expression ax squared plus bx plus c also has the same roots, which is what we applied here. So we know that this equation has the same roots as this equation, but we need to find the n value that gives us this equation. And you find the n by substituting coordinates of the point into this equation, and that gave us n equals -1. And there we have our equation. Now, what you could do is test the point 2 and -5. So replace x with 2 and see what happens to y. See what value you get for y. You should get -5. And that shows that this point lies on this curve. And we also know that this curve has the roots 3 and 7. Why? Because it's of this form. It's just a case where n is -1. And we know the roots of this equation are the same as the roots of this equation. And we know that the roots of this equation are 3 and 7. We're going to have another example. So let's try another example. So we have, imagine you're given, so this is just a rough sketch of a curve. Just a rough sketch. Imagine you're given now this is a quadratic curve, but it intersects the x-axis at just one point, this point here, and this point has an x-coordinate of 3. Now, I'll give a point on this curve, point 1. The point 1,8 also lies on the line. Now, we need to determine the equation which was plotted to give this curve. Now, the first thing to do is construct an equation from the given roots. We know that this equation has repeated roots, so we can say, well, the first root is 3, and the second root is 3. Constructing an equation, because x1 is 3 and x2 is 3, and this gives x squared minus 6x plus 9 equals 0. And we know that the equation, you just replace y, is 0, the 0 with the y, you get y equals x squared minus 6x plus 9. I mean, actually, if you replace 0 with the y, you get x squared minus 6x plus 9 equals y.
Swapping the left-hand side and right-hand side then gives this equation.
Okay, so we have an equation whose roots are 3 and 3, one of the conditions. But the second condition that must be satisfied is that the equation must be such that the point 1,8 lies on that equation. So the next thing to do is, well, say that, well, the equation y equals n times x squared minus 6x plus 9 also has these roots. But for a certain value of n, this coordinates of this point will satisfy the equation. And you determine the n value by replacing, so let's look, the x coordinate here is 1 and the y coordinate is 8. So replace y with 8 and x with 1, and that gives the following. 8 equals n into 1. That's 4. If you simplify it, this gives 4. So 8 is equal to 4n. 4n is equal to 8. N is equal to 8 over 4, which is 2. So n is 2. So the equation we're looking for, the equation of this graph, is y equals, instead of n, we have 2, because the term n is 2, x squared minus 6x plus 9. This equation has the same roots. It has the repeated roots 3, because it's an equation of this form. It's just a case where n is 2. And because we determined by substituting, replacing x with 1 and y with 8, we determined the value of n that causes the, basically we determine the value of n, which is such that we get an equation where this point satisfies that equation. So we have this equation, y equals 2 times this, which I can rewrite as 2x squared minus 12x plus 18. So what I'm trying to say is this equation has repeated roots 3, and also the point 1,8 lies on the equation. Let's test the point 1,8. So if I replace x coordinate is 1, y coordinate is 8. If I replace x with 1, I get 2 times 1 squared, which is 2, minus 12 times 1, which is 12, plus 18. I get y equals 18 plus 2, 20 minus 12, which is 8. So as you can see, this equation has roots, repeated roots 3, and this point also lies on our equation. You can try solving this equation for its roots by replacing y with 0 and using the quadratic formula, any appropriate technique, and you find that the roots are x equals to 3. So the procedure again, when you're given an equation, you're given its roots and you're given a point on that quadratic equation. You construct a quadratic equation from the given roots. Then you note that, well, an equation of the form y equals n times whatever this you get on the right hand side here also has the same roots. Then you determine the value of n. You determine the appropriate value of n by finding an equation which is satisfied by this point. So you replace x with 1, and you replace x with the x coordinates of that point. In this case, replace x with 1 and replace y with 8. And that gave us a value of n. And therefore, we had the equation required, y equals 2 times x squared minus 6x plus 9. And that's our answer. And here we just did a test. We just tested the point, and we found out that this point, the coordinates of this point actually satisfy the equation. And I've asked you to try and determine the roots of this equation, and you find that its roots is 3, but basically 3 repeated. So the whole idea of recognizing a quadratic equation given a point which lies on its graph and given its roots should be understood. It's a bit tricky, but trust me, with practice you'll become perfect in doing this. But I do agree that it's tricky. In case you have any trouble with this, just send any questions you have. Here's another example question. This time we have the plot of a linear equation. In fact, this is a line here, and we're told that it has the equation y equals 3x plus c. We're also given a point that lies on this line. The point has coordinates 2, 10. And the question says, given that the equation of the given linear graph below is this. So this is the equation, and that the point 2, 10 lies on the graph, determine the value of the unknown constant c. So we have an equation here, y equals 3x plus c. And what do we know? We know we have a point, and we know that the coordinates of this point must satisfy this equation. So if I replace x with the x coordinates of this point and y with the y coordinates of this point, the left hand side and right hand side of this equation must match, i.e. the equation must be satisfied. So I'm going to replace y with 10. I'm going to replace x with 2. And that gives 10 equals, in fact, my brackets might look like C's. 10 equals 3 times 2 plus c, which gives 10 equals 6 plus c. So swapping left hand side and right hand side gives 6 plus c is equal to 10. I'm making c the subject formula because I'm trying to determine c. Subtracting 6 from both sides gives c is equal to 10 minus 6, which gives c equals 4. So what's the main idea of this question? So basically, the question says determine the value of the non-constant c. So we determine it. How? Well, we know that when you have an equation and you have the coordinates of a point that lies in that equation, or rather, when you have the coordinates of the point that lies in the equation, you know that the coordinates of that point must satisfy the equation. I.e., when you substitute the coordinates of that point into the equation, the left hand side and right side of the equation must match. So we have an equation here. This c here represents a number. We don't know what it is, but all we know is that when I replace x with 2 and y with 10 in this equation, the left hand side and right hand side must be equal. And that's what I did here. And I've simplified to get c. Here's a final example. It says, given that the points, the coordinates 1, 4 and 3, 10, lie on the graph of the linear equation y equals mx plus k, determine the values of the unknown constant m and k. So hold on. I have the equation of, I have a linear equation. Now, m and k are constants. There's some numbers. We don't know what they are. So we need to find what the numerical value of m and the numerical value of k. Now we're told that this point, let's call it A, lies on that line. We're also told that this point here also lies on the line. So let's start with the first point. Because point A lies on this line, it means that when I replace x with its x coordinate and I replace y with its y coordinate, the equation must be satisfied. I'm going to replace y with the y coordinate to get 4. I'm going to replace x with the x coordinate, which is 1. So m times 1 is m. So this is what I have. So I'm going to call this equation 1. I'm going to do the same thing with b. Replace y with 10. I'm going to replace x with 3. It's x coordinate. So that gives m times 3, which is 10 equals 3m plus k. So now, By substituting the first point into the equation, I got equation 1 here. By substituting the second point into the given equation, I've gotten another equation 2 here. So now I know that I'm looking for what m and k are, but I know that m, from this equation, I know that m plus k is 4. And from the second equation, I know that 3m plus k is equal to 10. But I need to find m and k. Now what we have here is just problem of solving simultaneous equations, which you've done. So we can use the method of substitution or the method of elimination. I'm going to use the method of substitution. Now, from this equation, which is the same as equation 1, I just rewrote it. I just swapped the left and right hand side, same for equation 2. From equation 1, m is equal to 4 minus k. So I've made m the subject of formula in equation 1. Now I'm going to replace m with 4 minus k in equation 2, so that we just get an equation simply involving just k's. So we just have one unknown. Simplifying this gives 12 minus 3k plus k equals 10. This gives 12 minus 2k equals 10. This gives minus 2k equals 10 minus 12, which is minus 2. So I just subtracted minus 12 from both. Subtracted 12 from both sides. And this gives 2k equals 2 if you multiply through by minus 1. And this gives k equals 1. So now I know that k is 1, but I need to determine m. Well, m is 4 minus k. Therefore, m is 4 minus, what's k? K is 1. The numerical value of k is 1. So m is 3. And we're done. We now know that m is 3 and k is 1. And we did that by using the fact that when a point lies on the plot of an equation, the coordinate of that point must satisfy that equation. This is our equation here. We know that this point A lies on this equation. So when you replace x with 1 and y with 4, we get this equation. Why? Because we know that since this point lies on this equation, this point's coordinates must satisfy this equation. When this point's coordinates are substituted into the equation, so when you replace x with the x coordinate and y with the y coordinate, the left hand side and right hand side must be equal. So we have an equation here. We did the same thing with point B. We got another equation. The first equation told us that m plus k is 4. The sum of m and k is 4. Second equation told us that when you multiply m by 3 and you add k, you get 10. Now we're trying to find m, a numerical value for m. I'm trying to find a numerical value for k. And if you have a sharp eye, you can just see that this is a simple case of having two equations in two variables, and you can solve them. This is basically a simultaneous equation problem, and you can solve such problems either by using the method of substitution or the method of elimination. I used the method of substitution, and I got a value for k as 1 and a value of m as 3. And that's all. So just to repeat, when a point lies on the plot of an equation, its coordinates must satisfy that equation.